How terrifying is a level 7 civilization in the universe? To them, humans are as insignificant as ants. By the time a civilization reaches level 7, it has likely completed the process of becoming purely energy-based, capable of existing independently of matter. At this stage, they may even be able to alter the fundamental laws of the universe, exerting absolute control over certain regions of space and preventing other civilizations from entering. According to the Kardashev Scale, civilizations were originally categorized into 3 types: Type 1 planetary, Type 2 stellar, and Type 3 galactic. Humanity as of now is only at about level 0.7, not even a full Type 1 civilization, because we haven't mastered controlled nuclear fusion or fully harnessed all of Earth's energy resources. As scientific understanding of the cosmos advanced, it became clear that even Type 3 civilizations weren't necessarily the pinnacle, so Types 4 through 7 were added to describe increasingly advanced stages. These expanded categories now encompass the full arc of technological evolution for intelligent life, from basic energy control to complete energy-based existence. For us, it might take about 300 years to fully harness Earth's resources. After that, humanity would begin its transition to a Type 2 civilization. The entry point into this phase is the Dyson Sphere, a colossal structure designed to enclose a star like the Sun and harvest its energy. Because the Sun makes up 99.86% of the solar system's total mass, we would likely need to dismantle many planets to gather enough raw material to build such a structure. Astronomers estimate that constructing a Dyson sphere around a star could take hundreds of years, during which time the star's brightness would fluctuate irregularly, a phenomenon that could reveal humanity's location to the rest of the universe. In fact, the unusual dimming of Tabby's star, observed by astronomers, has led some to speculate it may be caused by an alien civilization building a Dyson sphere. For a Type 3 civilization, the energy of individual stars is no longer sufficient. Instead, their goal becomes entire galaxies like the Milky Way, with its hundreds of billions of stars and a diameter of 200,000 light-years. In addition to enclosing stars in Dyson spheres, they might also draw energy from supernovae and black hole jets. At this point, energy is no longer a concern for Type 4 and 5 civilizations. What matters now is mastering the fabric of spacetime itself, exploring wormholes, spacetime folding, multiverses, and higher dimensions. In these domains, they could easily obliterate lower civilizations through dimensional suppression. Once a civilization learns to navigate and manipulate multiple parallel universes, it becomes a Type 6, a trans-universal civilization. Beyond that, the level 7 civilization emerges one that has fully transcended material existence, becoming pure energy. At this stage, the universe is it, and it is the universe. Such a civilization may be unique, with no individuality left. All consciousness merges into one being, and it's entirely possible that the universe we live in is merely a dream constructed by a level 7 civilization. Many scientists have speculated that we might be living inside a simulated universe. And curiously, astronomical observations have shown striking similarities between the structure of the universe and the human brain. The distribution of galaxies mirrors that of neurons. Perhaps we are nothing more than a fleeting dream in the mind of a cosmic brain, but due to the scale of time and space, this dream feels endless to us. Still, physics demands evidence. No matter how elegant a theory is, if it can't be proven or disproven, it cannot be accepted as scientific truth. But this raises the question, is it even possible to verify or falsify everything that exists in the universe? While telescopes like Hubble and James Webb peer into the deep cosmos, billions of light-years away, physicists continue probing the innermost secrets of matter. Quantum mechanics tells us that everything in the universe is composed of subatomic particles, photons, electrons, and others. These particles behave both as particles and waves, a property known as wave-particle duality or quantum superposition. This is what makes them quantum. In truth, the term quantum doesn't refer to one specific particle, but to a category of particles. Among them, the most famous is the Higgs boson, also called the God particle. The Higgs boson is a particle that emerges within the Higgs field. It's responsible for giving mass to all other particles. Without it, our universe would not exist in any recognizable form. Without the Higgs, every particle would behave like a photon, flying at light speed and unable to slow down to form atoms. In physics, the Higgs boson is legendary, the bridge between mass and masslessness, between the visible and the invisible. It's the very foundation of every particle and of the universe itself. But the journey to confirming its existence was far from easy. First predicted in 1964, it wasn't officially discovered until 2012 in a particle collider. Even now, our current colliders lack the power to fully unravel the mystery of the God particle. What's more, recent data suggests the Higgs boson may be decaying in ways that contradict the predictions of the Standard Model, hinting at deeper, unexplored physics. This could potentially overturn everything we thought we knew about the microscopic world. In the current Standard Model, the Higgs field permeates the entire universe and particles are constantly moving through it. Photons are the exception because they have no rest mass and travel at the speed of light. Other particles, once granted mass via the Higgs field, interact through the four fundamental forces: strong, weak, electromagnetic, and gravitational. The first three govern the microscopic world, while gravity rules the cosmos. To reach even deeper into the heart of matter, high-energy physicists are now proposing the construction of a new kind of supercollider, a massive machine designed to accelerate particles to near-light speeds and then smash them together. These collisions can sometimes reveal particles that were previously unknown. The Higgs boson was discovered this way, though it appears only about 1% of the time, making it extremely difficult to study or harness. The only solution is to build bigger accelerators with longer magnetic rings to increase the energy density at the moment of collision. That's the only way to generate enough fragments to detect new particles. In the big picture, although 20th century physicists believed the Higgs boson was the final missing piece of particle physics, current findings suggest it's only part of something far more complex. And in the foreseeable future, as new supercolliders come online, we are certain to discover many more particles and perhaps new truths about the universe itself.